Welcome to Basic Embedded Systems Training. In this session, we will cover 8051 timers or counters. 8051 supports two timers or counters, that is timer 0, timer 1, two counters, counter 0, counter 1. So the timer is used as delay generator. So for these timers, the clock source is crystal frequency. So which counts number of clock pulses generated by the oscillator. And second one, so the event counter, for this event counter, clock source is external input pulses. For example, the number of pupils passing through an entrance, the number of wheel rotations, any other event that can be converted to pulses is completed by using this counter, which counts number of clock pulses generated on external signal. So that is the basic difference between timers and counters. So the registers used in timers or counters are timer 0, timer 1, 16-bit registers. So timer 0 is again divided into two 8-bits. Timer 0 lower order, timer 0 higher order. Timer 1 is divided into two 8-bits. Timer 1 lower order, timer 1 higher order. In addition, these to control timers, we require timer control register. To set modes, timer mode register is available. So these are the four registers used in timers or counters. The basic registers of the timers. Both timer 0 and timer 1 are 16-bit registers. These registers stores the time delay as a timer, the number of events as a counter. Timer 0 is available on two 8-bits, TL0, TH0. TL0 is called as a timer 0 lower byte, TH0 is called as a timer 0 higher byte. And timer 1 is available on two 8-bit registers. TL1 is called as a timer 1 lower byte, TH1 is called as a timer 1 higher byte. Because the 8051 is 8-bit architecture, so the capability is 8-bit, so that all 16-bit registers are internally available on two 8-bit registers. Then only CPU can able to initialize that registers. Each 16-bit timer can be accessed as two separate registers of lower byte and high byte. First one is TMOD register. TMOD register. So TMOD registers, if you observe this TMOD register, it is 8-bit register. So first 4 bits are reserved for timer 0 and second 4 bits are reserved for timer 1. So this timer 0 contains again M0 and M1, that two for mode selection bits, 00 mode 0, 01 mode 1, 10 mode 2, 11 mode 3. So total operates on 4 modes, mode 0, mode 1, mode 2, mode 3, because the 2 bits 2 power 2 is 4 selection lines are possible. And next one is C by T bar. It is actually T bar, C by T bar. So C indicates that counter, 1 is counter, 0 is timer. So and this one is gate bit, so that decides the internal or external. Okay, and it is for lower 4 bits are reserved for timer 0, and higher 4 bits same bits are repeated, M0 and M1 for mode selections, C by T bar for counter or timer selection, internal or external control with the help of gate signal. So that is called as timer 1. Okay, and next one is T mod register. Gate 0, already we discussed that gate 0, if it is 0, timer or counter counts only when T or 0 or 1 control pin is set. If timer gate bit equal to 1, the timer or counter counts only while TR 0 or 1 control pin is set, and in addition this INT 0 or 1 pin is high, because 0 indicates that internal selection, 1 indicates that external selection. If it is internal, then only depends on TR, timer run control bit. So if it is external, it depends on timer run control bit as well as INT pin. Okay, and next one, C by T bar. So counter or timer. 0 indicates that timer operation, 1 indicates that counter operation. Gate bit. For every timer has a mean of starting and stopping. So if gate equal to 0, internal control, already we discussed that the start and stop of timer are controlled by the software. So that is called as a set or clear by the timer run control bit TR0 or TR1. If gate bit equal to 1, external control, so the way of starting and stopping the timer by software and an external source. So timer or counter is enabled only while INT pin, that is INT 0 or INT 1 pin is high and the timer run control bit TR0 or TR1 is set. So that depends on a gate bit is 0 or 1. If it is 0, internal control, 1 external control. And M1 and M0, these two are the mode selection bits. So 00 mode 0, 01 mode 1, 10 mode 2, 11 mode 3. Sir, what is the difference between these four modes? First one is mode 0. In mode 0, timer operates in 13-bit timer mode. So that 13-bit also 8-bit from higher order called as a TH0 or TH1 and 5 bits from lower order TL0 or TL1. Okay, so timer 0 is also known as 13-bit timer or counter mode. And next, not timer 0, sorry, mode 0. And mode 1 is 16-bit timer mode. 16-bit timer mode. So here both timers and counters operates at 16-bit. Operates with 16 bits. So lower 8 bits is loaded into TL0 or TL1. Higher 8 bits is loaded into TH0 or TL1. TH0, sorry, TH0 and TH1. And next one is mode 2. So mode 2 is also called as a 8-bit auto reload mode. 8-bit auto reload mode. So here 8-bit auto reload timer or counter is supported in mode 2. So always TH0 or TH1, that indicates that timer higher order 0 or 1 holds a value which is to be reloaded into TL0 each time it overflows. So that indicates that the operation counting is through TL0, but after completion of first overflow or completion of every overflow, automatically the initial value is loaded into TL from TH0 or TH1. Okay, and next one is mode 3. So mode 3 is also known as a 116-bit timer to 8-bit timers mode, also called as a split timer mode. Okay, so mode 0 13-bit timer mode, mode 1 16-bit timer, mode 2 auto reload functionality, 8-bit supports, and mode 3 splitted timer mode. So this splitted timer mode supports both 8-bit and then 16-bit. Okay, and next one is TCON register. So TCON name itself timer control register, which contains 8 bits. First one is higher order TF1, indicates that